I can't believe how long went by before someone asked for help with this one. The Submarine 6 marker. Okay, so then we get to part C, the extended writing part. What I'm going to do is model for you what I'm thinking as I read the question. And this is really very much like me reading the question for the first time, because I haven't actually looked at this question for a very long time. So I know that it's a horrible question. I remember that the mock was horrible, but I haven't actually looked at the question. So you're going to get a pretty real example of me thinking my way through it. So let me model how I would plan to answer this question to see if that helps you. A submerged submarine is stationary. As soon as I read that word stationary, I am thinking balanced forces. I am thinking that means there is no resultant force on the submarine, because if it's stationary, nothing is changing. Therefore, Newton's first law, all the forces acting are balanced. There is no resultant force to cause a change. The engines are put on maximum power. That's a bit mean, really, isn't it? But in topic 3, in energy, we talk about transferring energy and transferring energy quickly. We'll do much more on power in year 11. But power is to do with how quickly you transfer energy. So this means there are lots of joules every second being transferred. Okay, lots of energy being transferred every second. And that means that there must be lots of force applied from that transfer of energy. So we're talking big force from lots of energy every second. That big force that's being applied is the force we've been thinking about through the question of thrust. We are told in the next bit that the submarine moves forwards. Now that tells me a lot of very important information. First of all, there must now be a resultant force. There is a change. There is a stationary object that is now moving forwards. It's accelerating forwards. Therefore, there must be a resultant force because this is now unbalanced. So I'm thinking about that in there. And that unbalanced force, there's going to be a resultant force. That resultant force to accelerate this object is going to be forwards in direction. And it's going to be the thrust. So the thrust force is going to be the force that contributes to be the leftover forward resultant force that changes the movement of this stationary submarine. The engines maintain maximum power. Now that means the energy every second is not changing, it's constant, which means that this submarine will be forced in a constant way. The force will be constant at that point. That's what that's telling me. So if everything is being maintained constantly, that's telling me the forward force is constant. The resistance force will be the water resistance. So the forces resisting the movement of the submarine increase as the speed increases. Well, this is just like air resistance. If you're moving faster through the water, then the water is going to hit you more often and harder. So there is going to be more force as you go faster backwards, trying to resist that movement. That means that if the resultant force is the overall force left over from this constant force pointing forwards, but this ever increasing backward force, that at the start, when the force backwards is very small, the water resistance isn't very great because you're not moving very fast, so the particles aren't hitting very hard, then you're not going to have much resistance. You're going to have most of your resultant force all forwards, accelerating rapidly. But as you go faster, the water hits you harder, and so this resistance force is getting bigger. That means the resultant force that's left over is going to get smaller and smaller. Eventually, you might even get to a point where those two forces balance. But let's see whether we get there. Let's read on in a moment. But this part of the question here, the forces resisting the movement of the submarine increase as the speed increases, is saying to me that at the start you've got a balanced force situation. Then you unbalance the forces by turning the engine's on. So there is this enormous forward resultant force. This really big forward force accelerates the submarine forwards rapidly. But then as the submarine tries to move forwards and get quicker and quicker and quicker, the water hits it harder and harder and harder. So the resistance forces pushing back on the submarine, they increase, which means that over time the resultant force forwards decreases. Therefore the acceleration will decrease. It's still moving forwards and it's still getting faster as it moves forwards, but the rate at which it moves forwards, the rate of acceleration, is decreasing over time. And eventually it could get to a point where those two forces balance and you've basically got terminal velocity, which you might have thought about as a parachuting example before, but here you've got a horizontal terminal velocity if that happens. So let me just read on. The submarine remains horizontal, which makes everything easier because we haven't got to think about any vertical forces at all. Explain how the forces acting on the submarine affect its acceleration up to and after it reaches its maximum possible speed. That's terminal velocity. Okay, so what is happening is eventually the water resistance is going to have a force that's exactly the same magnitude or size as the thrust force that's constant. When those two forces balance, what's going to happen is then nothing can change about the submarine. But it was already moving when those forces balanced. So it will continue to move forwards because nothing can change. It can't change its direction, it can't change its speed, it can't get faster or slower. So it will continue moving through the water at exactly the same speed until something changes. You turn the engine off, you put it into reverse, whatever that might be. But this question's not asking about that bit now. So through that thinking through and reading the question, I've formed my answer really. I've got an answer, haven't I? I hope it's helped you to think about it. If I was now going to write a 6-mark answer, I would answer this in 3 stages because there are 3 parts to this question. So I'd structure my answer like this. I'd have, at the start, I'd talk about stationary. Then I'd talk about the constant forward force in the second part. Sorry, I can't write as quick as I can talk. Look. And then I would talk about terminal velocity in the end. So I would be saying something like, the submarine is stationary at the start because the forces are balanced, there is no resultant force. When the engines are turned on, they cause a forward force that's constant, and therefore, with no immediate resistance force backwards, the submarine accelerates in a forward direction. However, as it moves through the water pushes back, hits it harder, and the water resistance force, which opposes the motion, gets bigger and bigger and bigger. Because of that, that means the resultant force gets smaller and smaller and smaller, and therefore the acceleration, or the rate of change of velocity, decreases in time, even though the submarine is still speeding up and moving forwards. And eventually, the submarine has got to a speed where it's actually possible for the water to hit back on the submarine as hard as the submarine is being pushed forward by the thrust. And that's part 3, where terminal velocity means that the forces become balanced again, and therefore, like Newton said in his first law, if the forces are balanced on the submarine, nothing can change about the submarine. Therefore, it was moving forwards and it will continue to move forwards at a constant speed. I hope that was useful and has helped you think about what is really a very challenging question.